Okay, so today we are going to discuss about the rules of naming alkyls. So we give the name so we can determine that which group is that. So we are going with the first rule, that is consider the parent alkyl and select the longest possible chain of carbon atoms, whether it is straight or branched. Okay, let me write here. Rule number 1, select longest chain possible. Okay, so this is select the longest possible continuous chain, okay, of the carbon atoms, whether those are straight or branched. Okay, okay. So let's take one, we can say alkyl radical, that I'm taking the hexane. So here the hexane C. Okay, so this is the chain of heptane. So heptane formula is C7H16. Okay, this is the heptane. So as you can see here, the 7 1 2 3 4 5 6 7 7 carbons and 16 hydrogens. So now let's give the numbers, longest possible chain we have to make. So let's give the numbers. If we will give numbers from here like 1 2 3 4 5 6, so this what we have, the branch chain. Okay, and for suppose if we will give the number from here, so you can see 1 2 3 4 5, so we have to select the longest possible chain. So here we are putting the number, so it is 6, and while from here these are 5, so this means from here it is the longest chain possible of the carbons. So this is the correct 1 2 3 4 5 6. So this is a longest chain and continuous chain, and this is the branch. They are saying whether that is straight or branch, so this is the branch chain. Okay, so this was the first rule. Now let me write here the second rule. Second rule is assign numbering on the C atoms of the chain from the end to which the branch or the radical is nearer. Let me write here, assign numbering on C atoms, carbon atoms of chain from that and where branch or radical is nearer. Okay, so here this is assign numbering on the C atoms, means carbon atoms. Put the numbering on the carbon atoms of the chain from the end. एक end से where branch or radical is nearer, जहाँ पे radical, this is a radical, from where radical is nearer, and we have to assign the numbering from where, when the radical is nearer. So let's take the example of hexane. Hexane formula is C6H14. Okay, so here we have CH. So now see, we have to assign the numbering where the radical, this is radical. Okay, This is what radical, where the radical is nearer. So as you can see, if we assign the numbering from here, 1, 2, 1, 2, 3, 4, 5. So here the radical is coming on the fourth number. While if we assign the numbering from here, 1, 2, 3, 4, 5. So here it is coming on the second number. So means where radical is nearer on the second number from this one side. So we will assign numbering from here, 1, 2, 3, 4, 5. Here we don't have to mean the longest possible chain. Here where the radical is near, we have to put the numberings. Okay, so this was second rule. Now let me explain about the third rule. Third rule is name the alkyl radical with its position. We have to naming the alkyl radical. Name the alkyl radical with its position. Okay, so here I'm making one structure. Yes, this is what we have the alkyl radical. Okay, now we have to name the alkyl radical with its position. Here you can see 1, 2, 3, 4 alkyl radical nearer. Okay, and how we will give the names? So here we have the methyl group in the alkyl radical. Methyl. So here CH3 we have the methyl. So here methyl is on the which number? 1, 2. 2 methyl. Methyl is attached with the second one. So 2 methyl. And which group is this? As you can see, 1, 2, 3, 4, 5. 5 carbons, and we have mm, mm, 12 hydrogens. 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry, 3, 4, 11. Okay, so we have 5 carbons and 11 hydrogens, that is butane. So here it is second methyl, means on the second number methyl is attached. This is the methyl formula. Methyl. On the second number methyl is attached, and we have this one whole structure is of the butane. So naming will be giving like this: 2 methyl and butane. So now let's move towards the fourth one rule, that is basically if the same radical appear. Let me write here. So here I wrote the fourth one rule. So what they are saying, if the same radical appear more than once, like here we have this one radical, okay, you can say this is radical. If we have the two radicals more than once, okay, so for example 2, 3, more than one in the chain, if we have the two radicals or more than two or more than one in the chain, the numbers of alkyl radical is expressed by the prefix. So what they are saying, alkyl radical is expressed by the prefix. So the name of the alkyl radical with that di, tri, tetra means where that will be, this is the dry. Where there will be the more, so number will be giving like that. So let me write here, then I will explain you. CH3. This is the structure of pentane, okay? CH. Here we have S3. How will give the radicals? We have to complete the carbon valency, that is 4. Okay, so here you can see, like, let me give numbers 1, 2, 3, 4, 5. Okay, so now where the alkyl radical is present, more than once. Here are the two alkyl radical. I mean more than one. This is fine. Alkyl radical is present with prefixes. So here this is 1, 2. Second number and on the third number. So 2, later 2 and 3. Then here we have 2 formulas of methane. Means here 1, 2. So again we write the 3. And here we have trimethyl. And we have to put the prefix, that is tri. How tri? Because here we have the 3 carbons and here we have the 1, 2 and 3 group of methane. So that we trimethyl pentane. This is the structure of pentane. Okay, so one most important thing I can tell you, that is over here. This one is the N, means single bond. And this one is represented by E. This is N and this is E, double. And triple is represented by ein. Okay, so let me tell you about the 5th rule. So here we have the 5th group. So let me write here the 5th rule, that is when there are 2 or more separate alkyl radical in a chain, so they are designed in alphabetical order, like ethyl before methyl and methyl before propyl and so on. So what in this rule they are saying? They are saying where there are 2 or more separate alkyl radicals, where there are 2 or more alkyl radicals, separate alkyl radical, okay, in a chain. So they are designed in the alphabetical order. Like if that is ethyl, methyl, if we are having the ethyl, so we will put first ethyl. And if we have the both, so we will put ethyl, because in the alphabetical order E comes first, then M comes. So we will put the ethyl first, okay, then methyl, propyl. Methyl comes first after propyl. So propyl, if we have both in the group, we will put the methyl first. So that we make here. This is the structure of pentane. So let me give here numbering 1, 2, 3, 4, 5. Okay, so now here what we have, this is the third one, the separate alkyl radical, and this is the second one. Here the numbering represent. So what we have, we have this one ethyl, the CH3 and CH2, and here we have CH3 only. So this is, if we put CH3 and CH2, this is the formula of ethyl. Okay, so here we have put ethyl first. Here ethyl and methyl are both. This is the methyl and this is the ethyl. So what I said, in the alphabetical order, E comes first, so we will write the ethyl first, and ethyl group is on the third one, radical 3 ethyl, okay, and methyl is on the second one. Then we have 2 methyl And which group is this? Pentane. Okay, so this is how we used to give the alphabetical order to the structure of any, we can say, rules. Okay, so now third sixth group or sixth rule, which is when separate alkyl radical occur at the same position. What? When separate alkyl radical occur Okay, so let me explain you. Okay, so what they are saying, when the separate alkyl radical occur at the same location, means if we have the two radicals and they are at the same location. Okay, so on the C atoms from the either side of the chain, so on the carbon atoms, the in the carbon chain is numbered from that end to with the large radical. So we will give the naming where the large radical is nearer. Okay, so let me make here the structure of hexane. Okay, so here it is basically the structure of hexane. So here you can see they are saying where the large radical is nearer, we have to give the number from that. So 1 2 3, here it is 3, 1 2 3 4, large radical is on the fourth number from this one side, and from this one side large radical is on third number. So we will give name from here. 1 2 3 4 5 and 6. Here large radical on the third one, and here we have the second. So here what we will say, and this is the CH2CH3 is the ethyl. So we have the 3 ethyl because in the third number it is present, 3 ethyl. In the fourth number we have the methyl, 4 methyl, and this, which is this one structure, this is hexane. Okay, so this was the saying in the sixth one rule. Now last one, that is 7. In the end, name of the parent cell is named as the alkyne with respect to C atoms. Right here, in the end, name of parent chain is named as alkane with respect to numbers of C atoms. So what they are saying, so in the end means in the last, the name of the parent cell is named as alkane. So the name of this chain is known as alkane. These all are the alkane chain because ANE, alkane. With respect to number of C atoms, with respect to how we recognize that this is the parent cell is named as alkane, because with the number C atoms. Okay, so in the end these are saying this. In the end, name of the parent chain is named as the alkyl and with respect to C atoms. Okay, so this was today's lecture. Hope you enjoy. Bye bye.